Let us discuss about Ziegler Natta catalysts. What are the specialty of Ziegler Natta catalysts? They are heterogeneous catalysis. Okay, what is meant by heterogeneous catalysis? Heterogeneous in the sense that the reactants and the catalyst will be in a different phases. Okay, here reactants and catalyst will be in a different phases. Means here, for example, ethylene on polymerization will give polyethylene. Here we are using solid as a catalyst, whereas gaseous reactants can be used. Then it is called as heterogeneous catalysis. In Ziegler-Natta catalyst, two components are present. Here one is organometallic compound, another one is transition metal salt. What is the specialty of Ziegler-Natta catalyst is that we can use room temperature. The catalysis can be polymerization, can be even at room temperature also. And the catalyst is more stable even at 100 degrees centigrade. That is, it is thermally more stable, thermally stable catalyst it is. And here we can prepare a linear polymer also can be prepared. Linear and stereospecific polymers, that is syntactic or atactic, but they are stereospecific polymers are prepared here. Stereospecific polymers are prepared. That is a specialty of this polymerization. Okay, that is here. What is the structure of Ziegler-Natta catalyst? This structure, if you see this one, the structure of Ziegler-Natta catalysis is that here we are having chlorine with the titanium as a titanium is there. Okay, that is titanium is present here, and it is having a bridged bond also. Okay, that is R will be there, and here it is aluminum. Okay, that is and it is R. Trialkyl aluminum we are using as a co-catalyst. This part is from trialkyl aluminum. This is a transition metal salt. This is a structure of Ziegler-Natta catalyst. Generally in BSc, the structure of Ziegler-Natta catalyst is asked. Here we are having two components. One is organometallic compound is a co-catalyst. It is used as a co-catalyst. And what are the organometallic compounds that are generally used are triethyl aluminum, diethyl aluminum chloride, butyl lithium, butyl magnesium iodide. Whereas transition metal salts that are used are generally from 4th to 8th group metals are used, metal halides are used, that is titanium tetrachloride, vanadium trichloride, titanium trichloride, and dichloro dicyclopentadienyl titanium are used as a catalyst. Okay, they are coupled together. These two are coupled together in a solvent, that is hexane solvent, to form a homogeneous, heterogeneous suspension is formed. The specialty of this one is, as I said in the beginning itself, that it is a heterogeneous catalysis is the property of this catalysis. Then let us see the mechanism of Ziegler-Natta catalysis. Here, as we said, there are it is a chain reaction. In chain reaction, we know that there is chain initiation step is there. Okay, initiation step is there, and chain propagation step, and finally termination step is also there. In chain initiation step, what happens means alkyl, that is titanium, is going to be bound. Titanium tetrachloride is going to form a compound with aluminum, trialkyl aluminum or triethyl aluminum. Okay, triethyl aluminum is formed, AlCl, that is C2H5. For example, we want to prepare, that is triethyl or polyethylene, if you want to prepare by using ethylene. Okay, let us take up this one. That is here. When they are combined together, they are going to form a complex is formed where titanium plus 4. Here it is having titanium plus 4 state. It is converted into titanium plus 3 state here. Okay, that is titanium plus 3 state is formed. Okay, that is here we are having sorry. Here, the titanium plus 4 is converted, or that is completely reduced to titanium plus 3 state. Okay, that is one more aspect you have to remember. And titanium, what happens means here, titanium is having it is a octahedral complex is formed. Cl, there are 5 ligands of chlorine are there. But and one more thing is that there is a vacant site. That is most important is vacant site. Vacant d orbital is also present. It is having vacant d orbital, and it is going to be that is bound by this ethyl group. Ethyl group is going to form bond with this one, and with the loss of chlorine atom, chlorine will be lost, and it is forming a complex like this. Titanium is there, and titanium followed by C2H5, CH2, C2H5 means we can write it as CH2, CH3. Okay, then one chlorine is lost. Therefore, it is having again one more vacant site is still going to be present here. Chlorine is there, and here also one chlorine atom is there. But here one chlorine atom and one, we are having one chlorine atom here also, and one vacant site. This is what happens means this is nothing but the chain initiation step. Next comes second stage known as chain propagation step. Let us see about the chain propagation step. In this chain propagation step, we had to propagate. Okay, when what is done by polymer? Polymer is nothing but combination of monomer units. Okay, when you add ethylene to this one, CH2 double bond CH2 is added to this one. When it is added, it is going to form titanium is going to form another bond with this one. A pi complex is formed in the beginning actually. Okay, pi complex, pi bonding is going to be formed. Okay, that is, it is a pi bonding in which only a back bonding or only the pi bond is involved in the bonding with this titanium metal, CH2, CH2. Okay, then the normal, the remaining are as usual, that is CH2H5, CH2 and CH3 is there, which is existing, and this is chlorine. Okay, once this is formed, next step is chain insertion takes place. In this propagation step itself, one chain insertion, this CH2, CH2 that is present here, okay, this is going to be inserted, or else this bond is broken. Okay, here what happens means this bond is broken here. This bond that is present here is broken, and it is going to be formed, bound to this one, and this pi bond will form a solid bond. Earlier it was a completely partial bonding is there. Now it is completely bound to the titanium. As a result, it is going to form a complex, one more complex. The complex that is formed is titanium is there as usual. Titanium is there, but it is inserted. This reaction is called, this step is called as insertion. Insertion means this ethylene is inserted into this bond. The sigma bond that is there is inserting this one. That is why it is forming CH2. And we know that once it is inserted, this bond is going to be formed. This pi bond will be coming over to the titanium. Why? Because it is losing this pi bond. Therefore, the electrons are displaced and it is bonded to this titanium. And CH2 is there. And CH2, CH3, the lengthening of chain takes place by this insertion. That's we had to observe this one. And chlorine, and this is chlorine. And here also chlorine is there. And here we are having this, once it is inserted, and again empty orbital is formed. Again the repetition, again when it is bonded again with CH2. For example, let us assume that there are n number of CH2 molecules. Why? Because this reaction is repeated. this step is repeated. It is known as chain propagation step. In this chain propagation step here, all these are getting inserted into this one. Okay, that is because of this insertion again. Okay, that is repetition of all the steps takes place, and finally, what is inserted is here. It is n number of CH2, CH2 repetition of this. All the steps takes place, taken n number of times, followed by earlier one CH2, 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 CH3. CH3 takes place, and here this is titanium, this is chlorine, and this is chlorine as usual, and this is chlorine, and this is chlorine. Again, repeat, there is every chance. The last step or chain termination step, we know that in a chain reaction, the last step is known as chain termination step. Chain termination step, what happens means, okay, here let us assume that here this n, let us keep this n so that it is easy for us to understand the reaction. We can write this n somewhere else also. Okay, that is okay here. That is CH2, CH2n is there. Instead of this one, we can extend this H. Why? Because here, what is the use of this H? It is called as beta hydrogen. Okay, beta hydrogen is there. Beta hydrogen will be shifted now. Okay, how it is shifted? Let us see. Okay, that is here. This beta hydrogen that is there is shifted onto this one, and it is coming over. This bond is completely displaced. As a result, what is going to happen is the final step, we are going to have CH double bond CH2, that is a double bond CH2 taken n times CH2 CH3 is formed. This is the polyethylene or polyethylene is formed in this manner. This is about the Ziegler Natta catalysis. What we have observed is there are three steps in this reaction. One is chain initiation step is there. Whereas chain propagation starts in the second. From this step, it is nothing but chain propagation step, and the final step is chain termination step. Chain termination step. In the final step, what happens means the polyethylene is completely separated. Polyethylene is separated. It is known as termination step. In the propagation step, there are a number of reactions that is all the monomers are getting inserted. That is most important is all the monomers are getting inserted here. Okay, they are getting inserted into this bond. This is called as insertion reaction. Okay, that is about Ziegler Natta catalysis. Thank you for observing.